Hello, we are Team 10, and our original plan was to create a puzzle box that would be equipped with a couple of exercises for the user. One stage consisting of number translation from, for example, numeric to binary values, and one stage that requires the user to turn the box around until the orientation of it is correct and a message is showed to the user. We want to start off by saying that this video is more conceptual than it is showing off a finished product. And throughout this project, our team has faced different setbacks. And in this picture, you can see our project being very close to a working prototype, even though it may not look like that. At this stage, we have soldered together the pin strips to which we attached the Arduino Maker 1000, as well as soldering together the OLED screen, the Grove inertial measurement unit, the shift register, the resistor network, the lithium polymer battery, and the slider switch to control the current flow while we upload sketches to the Arduino to protect the components. We were able to control the LEDs with our buttons that work with intercept functions, and the inertial measurement unit showed the output values on the OLED screen, which means that all in all we had all we needed to complete the first and the second stages of the project. However, when we tried to upload the sketch that would test the transition from stage 1 to stage 2, we lost connection to the Arduino communication port, and it is no longer responding. This is a problem that we had earlier in the project as well, and we ended up changing the circuit design and sloping the Wi-Fi server that we initially had planned to use during the second stage of the project, as we thought that it might have been causing problems. But it turns out that the problem most likely lies elsewhere, and without re-evaluating our decisions and redesigning the circuitry, switching out the broken Arduino would most likely only break the new one. Next, we're going to look at a couple of videos of different parts of the project working by themselves to better give a visualization of how we planned to execute the different parts of the project. And in this short video, we have an early prototype of the first part of the project, the binary game. And this video shows only that the LEDs are controllable by user inputs from the buttons, but after this we implemented the code for the binary game itself, but we sadly do not have footage of the binary game as we did not think it necessary to film it because we thought we would have a working product in the end. But you can read about how it worked in the final documentation, but basically how it works is this. So, you have 8 LEDs, right? And every LED is either on or off. And according to our program logic, if an LED is on, this resembles a 1. And if it's off, it resembles a 0, like this. So in this case, if we would have been given the decimal value of 165, we would have to input 10, 100, 101. In this video, you can see the inertial measurement unit outputting its measured linear and angular values to the OLED display, which shows it to the user. And this data would be used to find the orientation of the puzzle box. This is needed in the second part of the game. I already briefly told you what the second part of the puzzle box is, but essentially the idea is for the user to decrypt an already encrypted message given to him or her by turning the box in the correct orientation. The user would here receive, for example, a message that says S5, S1, S4, S2, S6 and S5. And by turning the box so that each side is facing upwards one at a time, the program would reveal to the user the correct characters. This works by defining characters that correspond to each side of the box. This is how the arrays of string look like in the code. The messages also have their relative indexes shown in the code, but not to the user. This is simply so the program would know what index to choose during the decryption phase. This is how the former message revealed Newton. So, what's next? The things we need to finish this project are assembling the 3D printed box, fix the circuit design so that our components are safe while uploading code to the Arduino, and write logic for converting inertial measurement unit outputs to user inputs. And if we can do this, then the final product would be achieved. However, that involves pinpointing and solving the issues that we have. And you're going to have to read our final documentation in order to find out our plans about that. Team 10 thanks you all for watching. Bye.